So welcome to my presentation, last presentation on atmosphere. We have discussed different things, different components of atmosphere. We have discussed different layers, their characteristics, and we also discussed a few of the different gases, particularly the variable gases we are interested in. We discussed those gases, their characteristics. And now the last topic of this chapter is what is the, and it is very interesting also to know the what are the different other atmosphere which encompasses the other planets, and what are their characteristics. Does it look like they are like the atmosphere of Earth system, or they comprises of different type of gases? So let's see what are the different ways we can explain it. First of all, we should know that our Earth is unique. Unique in a sense of its position, and due to positions we have different sets of characteristics that our atmosphere have, and that is very suitable for not only human beings but also the other living organisms. So the Earth system, or the atmosphere of the Earth system, which is main components of this Earth system, is nitrogen and oxygen. So here some of the important things should be noted when we are going to discuss about the atmosphere of different other planets. One is, what are the main components of the atmosphere of that particular planet? For example, in case of our planet, that means our Earth system, we have most of the cases, most of the atmospheric phenomena is dependent on two major gases. One is nitrogen, another is oxygen. They are more abundant. They are more abundant gases in the atmosphere. Similarly, the other gases, other planets, they have different sets of major gases. Although they do have also oxygen or nitrogen, but maybe their percentage is very low. For example, we can start from Venus. The Venusian atmosphere, in their atmosphere, the most abundant gas is carbon dioxide, and a minor amount water vapor and nitrogen also present in their atmosphere. And such this Venus atmosphere, with these components, they also shows an opaque acid cloud that encircles the planets, and it's hiding its surface, so we cannot see the surface due to its opaque characteristics. The atmosphere is quite turbulent. That means the force of the winds in that cases, they are much more greater. And there is a twisting eddies. Eddies means to circle, encompasses the winds. And these winds sometimes also goes beyond the 125 mile per hour velocity. And this velocity is huge. So such like cyclones, or we can say cyclones and tornado, sometimes hurricanes, they have such velocity in their atmosphere. The another thing is, with these they have very thick dense atmosphere. Sometimes thickness is also important, because here the carbon dioxide is 95%, but other atmosphere, they also have carbon dioxide of such percentage, but there is a difference between the thickness between the atmosphere of different planets. And these cases, such like in Venus, they have 90,000 millibar air pressure on their ground. So in case of our atmosphere, like in Earth's surface, we have 1013 millibar. Can you remember it? We have only 1013 millibar on the surface of on per square inch area on the surface. But if you see the surface temperature, air pressure, if you see on the Venusian atmosphere, it is 90,000. That means huge, which is 90 times greater than the Earth. So what would be the experience if we go there? even we can live in there, but we will experience is such a weight that this pressure can be found if we go to under the water at a depth of 900 meter, nearly 1 kilometer. So nearly 1 kilometer, if all this water, how much pressure will give you on your body, you can experience that type of pressure in Venusian atmosphere if you just stand on the top of the ground of the Venus. Moreover, the thickness of the atmosphere of the carbon dioxide produces a strong greenhouse effect in there. Means if you have carbon dioxide, as we know, carbon dioxide is a greenhouse gas, and greenhouse gas has a characteristics that they can also uh, protect to go out the temperature from the atmosphere. So carbon dioxide has the capacity to make the available temperature inside the earth surface, inside the atmosphere. So in case of Venusian atmosphere, as carbon dioxide is much more, so what happened, the temperature which is coming from the sun, when they go into the Venus, so when it wanted to feed back, when it wanted to go back, that time they protect it and they increases the temperature. So the hot surface, which is nearly experience a temperature of 480 degrees centigrade. So now you think, first of all, very high amount of carbon dioxide, and also they have very fierce wind system. It is 120 meter, 25 mile per hour, and they also have a great pressure on the surface, 90,000 millibar at the ground of the Venus, and they also have very hot surface of 480 degrees centigrade. So all this makes that Venus is not possible to live by the any type of living organisms. Sometimes we can also think that if they have some water vapor and they have carbon dioxide, it might be possible that there are some plant species they can live in there, they can survive in there. But also we should to think about that with a high temperature 480 degrees centigrade, it is not possible to live any such type of organisms, any such type of plant species also in Venus. Such like Venus, we can also discuss about Mars, because Venus is in on side of our cases. On the other hand, Mars also looking like the Venus, but even though they have mostly the carbon dioxide, but their atmosphere is very thin. And so that when the atmosphere is very thin, that means the heat cannot be restored in there. So in case of Venus, you see it is 480 degrees centigrade temperature on the surface because of the thickness of carbon dioxide. On the other hand, Mars have also, most of them, they have carbon dioxide, but in case of Martian atmosphere, as they are very thin, so the heat are actually going out from the atmosphere, and thus the temperature of the Mars are much lower. Average temperature is minus 60 degrees centigrade because of its thin cold atmosphere, and there is no liquid on the Mars, and virtually no cloud system. As there is no liquid, so there is no cloud system also. Maybe some barren desert like landscape we can see in there. In addition, as the atmosphere is very low, that means their pressure is also very low, so it is only 7 millibar. So 7 millibar means you will not feel any pressure on you. So that on the ground, you may feel like such type of pressure, which can be also found in case of our Earth system. If we go to the go to an altitude of 35 kilometer above. So if you go top of the atmosphere, more than 35 kilometers in altitudes, you'll feel 7 millibar pressure on you. And that time, with this low pressure, again, it might be very impossible to tackle any type of living organisms to live in there. and also they don't have any liquid water system on them, so there is no cloud system also. And without the water, without the liquid, we again we cannot think about any such environment to live in. Occasionally, they have huge dust storms developed near the Martian system, and such storms may be accompanied by winds of several hundred kilometers. So it is also like looking like the a system of huge amount of the dust that can be carried out by hurricane or cyclone. And eventually, as the temperature is very low and they don't have any such type of pressure, eventually they will be settled down, and then a coat of this dust will you can find all over the ground of the Mars, and thus this is looking like reddish in color with this dust. So this is in the same way, we can also discuss about the atmosphere of Jupiter. Jupiter atmosphere, although they don't have much amount of the carbon dioxide, but their main component is hydrogen and helium, and a minor methane and ammonia. And with this one of the important characteristics of Jupiter's atmosphere is we can see some great red spot in there. What do you mean by these red spots? You can see in the figure these red spots, they are actually huge atmospheric storms. That means in this place the wind is moving, and such big why it is so big, because Jupiter is also big actually, and in Jupiter the system which is encompasses in this great red spot is sometimes very large, very large. And that's how you can also figure it out from the outside. And it is also counterclockwise, like it also in the counterclockwise in the southern hemisphere, such like in case of our atmosphere also. So if it is counterclockwise and it is moves, like it also carries a huge amount of the energy in there. And similarly, they have also, unlike the Earth weather machine, which is governed by the sun also. So Jupiter's massive swelling clouds appear to be driven by the collapsing core of hot hydrogen, as they have hydrogen and helium. These are their main atmospheric components. So that is driven by these clouds are driven by the collapsing core of the hot hydrogen. Energy from this lower region rises toward the surface, then it stirs the cloud layer into more and less horizontal bands of various colors. So here is another white spot also. So this spot is also very prominent, like great red spot in here and white spot in here. They are also very much important figures for the Jupiter's climatic system. Uh, like Jupiter's, if you see the great dark spot on Neptune. So Neptune's climate is looking like blue, but on the top of them, on the one side, there are some hazy. You can see this little bit dark color. This is also very prominent in Neptune's atmosphere. Neptune as atmosphere. In fact, the large dark oval on the Neptune appears to be a storm similar to Jupiter great red spot. That means here is also huge amount of the winds are flowing all the time and moving in a circle. And also you can see some white spot in here. This is white because it is made up of with some ice crystals of methane. So we can also see that things from the outside very prominently. And this is looking like some clouds in case of Earth system, which is named as cirrus. That means that means some fleshy and a very thin like cloud system, which you can also found in our atmosphere. So it can also be seen in the atmosphere of the Neptune. So if we just comprises all of them in a table, then you can see the average distance from the sun, which also triggered the average temperatures. Here the Mercury is 260 degree, 260 degree temperature, even though the distance is very nominal, but actually the Venus got the highest amount of the surface temperature because of its carbon dioxide, high amount of the carbon dioxide and thick atmosphere in here. I don't know what is the main components of Mercury, but all the other system you can see most of them are hydrogen in here. The far away planets and the planets which is very near to Earth's surface. Here you can see Mars and Venus is they have carbon dioxide, and in between them Earth we have nitrogen and oxygen. So why there is very little amount of the carbon dioxide in here in case of our cases? It should be that Venus is high amount carbon dioxide, Mars have high amount of the carbon dioxide, but why in between Venus and Mars, why Earth don't have sufficient amount of carbon dioxide? So the theory is perhaps carbon dioxide was abundant at a time in case of Earth system, but then the carbon dioxide had got their many sinks inside the Earth system. Inside the Earth system, we have some plants, a huge amount of the vegetation that has been grown up in here with the optimum temperature. And these life forms also taken from the atmosphere this carbon dioxide and converted their food like the glucose and oxygen, and that's why oxygen is increasing in the Earth system. On the other hand, now there is a balance between the last couple of thousands of centuries that oxygen and now nitrogen have in a good ratio in here. And carbon dioxide also we seen in other day that during last 1000 years the percentage of carbon dioxide was also very constant, but during last couple of decades the carbon dioxide has been increasing in a high rate. We can say last 100 years, and these on 100 years carbon dioxide shows a much more increasing rate in here. So thus before the increasing, the carbon dioxide has been locked up in different sinks. One such sink is the vegetation cover. Another sink is the ocean, because in the ocean this carbon dioxide can be very easily they can be stored inside the ocean, because in some plankton they can also reside on the top of the surface, and they can also take the atmospheric carbon dioxide inside them, and they can also move to inside the food chain. Food chain means those plankton has been taken up by different types of animals, marine animals, actually different fishes, different invertebrates, and different other sorts of fish and other animals, marine organisms. They are taken up this carbon dioxide, this phytoplankton and zooplankton inside them, and then those are also be eaten up by the big different larger types of the fish and other marine resources, marine organisms. And finally, when they died, their shell and everything has been deposited on the ground of the ocean. That means ocean has got a huge amount of the carbon dioxide from long time ago, and it is a great source, because scientists found that the amount of the carbon dioxide that has been stored already inside the ocean is 50 times greater than the atmosphere which is present in the atmosphere. That means 50 times more carbon dioxide has been stored inside the ocean at this time. So that's why carbon dioxide is very nominal in case of Earth surface. Now we have experiencing a good environment with less amount of the carbon dioxide. After that, there is another topic which is very much interesting and important also, a radio sonde. Radio sonde is a instrument that has been used to take up the different parameters from the atmosphere. It is very common system and very easy and easily tackle up, and they can be very easily transmit their information to the system. But the problem is every time we need a set of arrangements so that we can use it. So actually this is a balloon that has been sent to the atmosphere, and with the balloon we have settled attached we have attached some of the instruments such like thermometer and barometer and many others, so that we can get the information. This is radio sonde, and this is a light box also. This should be light box because that can be easily be flow with the involvement of the balloon, so that it should be very lighter in weight. And there is all of the there are a couple of things that should be included in there. First of all, there should be a thermometer so that we can understand the temperature of every time. Then there should be a humidity counter, which is electrically sending their electrical current across a carbon plate. And air pressure also can be measured through a barometer we can locate it inside the box. And how we know that what is the temperature of a certain height? We can know that because we also attach a transmission system with this balloon, so that this transmitter can also send us the signal, and with that signal we can understand the readings of those type of instruments. So this is a radio sonde. You can see the large balloon, and this is the box. Inside it there is a thermometer, a barometer, and chips all together. They have in here a radio sonde that is drop. Oh, another thing is there should be a parachute with that, because when the balloon will be burst out on the top of the atmosphere around 35 kilometer from the ground, the balloon will be burst out, and that time all these instruments, they will come back to the earth surface. And if you have a good parachute, so that it will not gonna be damaged, because we have to use it again and again. We cannot just say, okay, let's forget about the process. No, we can't say that. So that's why we need a parachute to join it. In modern development, we also include a GPS inside the box, because GPS means global positioning system. This global positioning system also very important to know the exact location of this parachute, or not parachute, of this balloon, so that we can identify the height and or the altitudes of this whole system. And then we can segment it, what are the temperatures that can be found in each of the altitudes. When winds are added, the observation is called Roine-Sonde. And when plotted on a graph, the vertical distribution of temperature, humidity, and wind is called sounding. So these are some definitions. Eventually the balloon burst out, as we said, and come back to again. And now most of the areas, this balloon has been escaped by the meteorological organizations. In such cases, Bangladesh Meteorological Department, BMD, is responsible to find out the data sets. And normally 2 times in a day, these balloons should be sent to the atmosphere, at least 2 times in most of the cases. And the time should be very even for each of the country, and the time should be usually at the time of correspond to the midnight and noon. That means 12 o'clock in the midnight and 12 o'clock in the daytime in Greenwich, England, according to the time of the Greenwich, England. So this is the time when all these all these balloon should be sent to the atmosphere, and then we'll get the data and we record it so that we can also make a comparison of different areas. We can also understand or what is the changes that can be found each of the areas. Now the question is why we don't go for the Protoy asked me that which gas is powered in the balloon. Normally, what are the gases? You can see also in different areas of Bangladesh also, the kids also love to have this. So different type of gases can be just very lighter gas, which can be introduced in there so that it can be flown up to the top of the atmosphere. It can be helium, it can be any other type of gases which can be easily go to the top of the atmosphere, and which is very lighter in a positions. Any type of gases which is around the same height of the same concentration of hydrogen and such like thing. Does Siam asked me, does radiosonic provide precise data of the temperature, pressure? Yes, obviously. They give us very precise data because they are taking these data on the real field. That means you are not analyze any data sets that is converted to other system. This is very real-time data, and as we send for temperature, we are sending it. We are giving one instrument. For humidity, we are giving another type of instrument, and for other know the pressure, we also give the barometer. So these are the instrument which we can depend on. Okay, and this dependency also give us the right information of that data. But the problem is sometimes it is not very well understood that these with the high amount of the wind system, sometimes it might not be possible to find out the exact location because of the high forces of the winds. So balloon can be also moved from a long distance, and when it again burst out, then when it wants to return, in many cases the instrument has been lost and damaged, and in that cases we cannot use this again and again. So this is one source of problem we have. Fahri Ali Imroz asked me, sir, how does the balloon come back to the specific place? Doesn't it drift away because of the wind? Is that why there is a GPS included? Yes, you can say that, but GPS has been included recently. But before that, you are very right. Sometimes we could not find out the parachute. We could not find out our systems together because wind can be take away from long distance. So normally normally in a positions, if you see this picture also, you see this is a field type ground. We should just start this experiment. Sometimes we can use it on different agricultural fields, or sometimes we can also use it in a barren, very large barren field, so that we can see where it will be it will gonna calm down. But eventually we are expecting to we are expecting to come back, but sometimes these balloons may not be come back to our earth system because, as you said, it can be driven out. But if you just included GPS in there, so that it can be now very easily to be pinpoint the area, whether even if you have the pin very fine precise locations, but think about when it wanted to come back, if it goes long distance away. So in that cases, even if you have the parachute, sometimes the box also be for will also be make a connections or make a heavy obstacles through different sets of buildings or materials, so that it can be damaged. It can be damaged. So you can get back, but sometimes it can also be damaged. So it is a procedure that we can expect that it will come back, but sometimes maybe it might not be possible that we can use it again. So little bit expensive, I should say, if we if our instrument has been damaged. And as here said in the last para, can you see that it is an expensive operation because many of the instruments are never retrieved. So it has been written also here that we don't have enough facilities that every time we can set up a new sets of this instrument and we can send it. It might not be possible. So that's why it is very expensive sometimes. Modern satellites, that as you said, modern satellites, the GPS system is also helpful in that cases. Any other question regarding radio sound or anything of different atmospheric composition? Do you have any question regarding that?
So I have a question.
Yes, please.
So why there is not a remote transmitter to control the balloon? That's how we can control the balloon from any control center or anything like that.
How can you control the balloon? Can you just explain a little bit?
Sir, we get the process we control, remote control cars and other things. Can we control the balloon?
Like drone or something? Yes.
Yes, that's the
Okay.
way I want.
Okay,
Yes.
drone can be easily be tackled out by your remote system, because the height of the drone is not too much. As you see, this balloon can go up to 35 kilometers. Uh, it might be little bit problematic that it can control from the ground. Yes, we can also control it. We can also get the information through transmission, but transmission and controlling is two different things, because if you wanted to control the balloon, then you need to add some other structures with this balloon. It is not only possible that with this lighter weight you can just send it and you can control it. Then you might need some of the hand of this balloon, and then you need some driving mechanism in there. So that will create that you need a full flight actually. So maybe the smaller flight you might need. So it
Sir,
might,
it will increase the weight also, sir.
yes, it will increase the weight. So you need a little flight rather than a balloon. So balloon is easy to tackle out the altitudes, because it can go up to 35 kilometers, which we are interested in, because most of the cases 35 kilometers is enough to know the situation, and we can also understand much of the environmental consequences which is governed within this range. Okay.
Sir, is it harmful for atmosphere if the balloon drops anywhere in the ground? There's many kind of instruments in there loaded. That's why.
Yes, that's what I'm saying. You cannot there is a parachute with that. So parachute can also help you to make it down slowly. Okay, so maybe it might not be very harmful for the human beings or the other living organisms, that it will gonna fall out on the top of the head of someone. It might not be possible because you have a parachute. But the problem is sometimes it can also make a collision with some structures. If the heavy, if you have a heavy wind in the lower atmosphere, and that time the balloon can migrate from long distance from your location, and then it is very tough for you that you have to go to a long distance. You have to go, you have to search, maybe you have to go 10 kilometers away from your location. So it is very tough and it is boring that every time if you wanted to go such a long distance and you have to find it out. So normally what we do, normally we do experience it in an open field. And when the lower atmospheric wind is much more calm down, it is not very tougher in a positions. If it is very tough, that means high wind is prevailing, maybe it is the right system. Any other question?
Sir, is there any information regarding at up to how much time, sir, it remains in the atmosphere?
Sorry, how much time?
Sir, it remains in the atmosphere, sir, the radiation.
How many times it is in the atmosphere we send?
ডিউরেশনটা কত যে
Like
যতক্ষণ
duration, sir.
বেলুন থাকে?
Oh, duration, I asked someone, she said it is normally within 1 hour it again come back.
আমি রেডিও সাউন্ডের কয়েকটা ভিডিও দেখেছিলাম, ওরা হচ্ছে একটা ম্যাক্সিমাম অল্টিটিউডে পৌঁছে গেলে তারপর ওদের এরকম একটা বক্স থাকে প্রোটেক্টিভ, ওইটা অফ করে দেয়। তাহলে যখন মেশিনটা নিচে পড়ে তখন মানে বেশি ভেলোসিটিতে পড়লেও হার্ম হয় না।
Does it have also parachute?
জি স্যার, প্যারাশুট সহই, কিন্তু যখন হাই অল্টিটিউডে যায়, যখন মানে রেকর্ড করা হয়েছে টেম্পারেচার এগুলা, তারপর হচ্ছে ওরা অটো একটা রিমোট কন্ট্রোল দিয়ে অফ করে দেয় বক্সটা, তাহলে বক্সটা অফ করে দেওয়ার পর হচ্ছে আর নিচে পড়লে অত ক্ষতি হয় না মেশিনটা।
I don't think so, because when you have parachute, if it is a very higher altitude, it might not be a problem. But the problem is if it go to a height of very too much height, then such like 35 kilometers away from the ground, it might be a problem for the other cases, because it can move a long distance. It might go to a very long distance. Is it used in Bangladesh? Ariful Islam asked me. Yes, it is also used in Bangladesh, but I don't know in case of Bangladesh meteorology department, they use it daily or not. But in Bangladesh, it is also used. Yes. What if it drops in the river or water bodies? Imon asked me. Yes, Imon. Yes, if it is drop into the rivers, we will gonna lose it. So no way we can think about, but I don't know. Someone said that we can also use it for a minimum height. That means maybe we are interested about 10 kilometer altitudes, so we can. Sorry. Maybe we can use it for 10 kilometer high altitudes, and then after 10 kilometers, if you have any system that we can just burst out the balloon, or we can just retrieve the gas from the balloon so that it can just come down after 10 kilometers. It might be possible. So in that case, maybe our full record data system, a full record of 35 kilometers will not get that, but it will also be fine that we can get enough information in that particular region. It might be possible. Any other question or any interest? So if you don't have any other question, then I can go a little another topics, that is sorry, after meteorology. Meteorology, this is the last topic of this atmospheric phenomena, because atmospheric phenomena included the meteorology, because meteorology is a knowledge that is governed by the anything which we can see in the atmosphere. This was the idea in previous times. So in a book of Aristotle in 340 BC, he wrote a book which is named as Meteorologica, which deals with anything in a different system. In that book, he included precipitation and the air temperature and many things. But later the scientist of that particular time, they thought anything which is in the atmosphere, which is in the atmosphere, anything, any substance, and that things come down to the sky, from the sky. They thought this is a term, meteorology, that can be used. That means they are meteors. But at this time, with the increasing of the information, we don't say meteors for all the things. For example, we don't say any meteorological components as mean like the hello, can you see now?
Yes, sir.
Okay.
Yes, sir.
So I was talking about that in the scientists of that time, they thought that meteors are those kind of things which is coming from the sky, anything that can be termed as meteors. But at present time, we don't say meteors for all the coming from the sky. We say only meteors, which is extraterrestrial sources that is coming from. But we do say hydrometeors of such kind of things which is related with water, such like ice or water particles or precipitation. So meteorology, you can say this is the knowledge which can deals about the atmosphere, the knowledge of the atmosphere and its phenomena. And who is a meteorologist? Meteorologist is a person who is very much skillful on related to science which deals with the atmosphere. That's mean the person who have a professional degree from the meteorology or atmospheric science. So meteorology or atmospheric science can be vice versa, but atmospheric science can cover a large more space, because in the atmospheric science we also discuss about climate change, their mitigation factors, and also nature, everything in there. On the other hand, normally the meteorology deals with the information of the weather context. In the weather context, they also discuss about few physical and chemical portions in there. Basically, the knowledge of the physics that can be included in the analysis of this weather phenomena. I'm not going to explain weather and climate because you know it. Weather means day-to-day condition, and
Sir,
climate.
I have a question.
Sorry,
Sir, are you sharing the screen, sir? We can't see the screen, sir.
you can't see.
No, sir.
Uh, let me handle it again. So I'm not finding any options properly. Yes. Can you see now? Can you see now the screen?
Yes, sir.
Yes, sir.
Okay. So weather can be a day-to-day condition. On the other hand, climate can be a situation of 1 minute, please. 1 minute. Sorry. Weather can be day-to-day condition, but climate can be an average of some many years. For example, it can be average of 25 to 30 years at least of any components of the weather. So it can say climate can be an average of weather. Okay, and the meteorology discuss those things in a particular region. The concept of the climate also important in case of to understand the variables of the weather, because sometimes temperature is average temperature is not enough to understand a particular occasion or particular region. In that case, climate also support you that how can it gonna change. So frequency in particular cases, the frequency of the string also help us to distinguish among the climates that have similar averages. So this is all about the weather and climate. This is the last topic of this chapter. If you have any more question, you can ask me. I see one question is Farial Imroz asked me, where is the Bangladesh Meteorology Department is located? The Bangladesh Meteorology Department mainly it is situated in Agargaon, the main office, but their sub office also can be found throughout different areas of the country. For example, in case of Chittagong, we have meteorological office in Pahartoli, and also we can also see another one in some of the cases. We also see some information we also taken from by the side of the Potenga by the airport. Farial Imroz also asked me, can't we go to a tour there to actually see how the radio sound works? I don't think so. I don't think so about the radio sound that you can see, because if they can, they have the options for every day for 2 options, then you can see at the 12 o'clock, we can see that, but it might not be possible because of the arrangement. But I can also ensure that once upon a time we went to Potenga, and we saw how they took the information of other things from the ground surface. That means they took the information of the temperature, sunshine, then wind, wind force, and many others, precipitation on the ground. So we can see those instruments and how they convert it to the weather chart. We can see that in going to Potenga. But in case of Bangladesh Meteorological Department of Dhaka, I don't think so, because I asked someone, they said, some of the person, they said we also use 2 times in a day radio sound, but I am afraid of whether they can allow us or not, because it is under the Ministry of I think Ministry of some other ministry like Defense, Ministry of Defense maybe. So it might be a little bit tough to arrange that tour. Any other question? Do you have any other question?
So I have a question.
Please.
If there is over 95% of carbon dioxide present in Martian atmosphere, why is it so cold?
I discussed that things because this is although this is 95%, but the portion is very thin. On the other hand, if you go to the Venusian atmosphere, that is very thick. That is the main difference. And
so
also,
if you release a huge amount of CFC gas there, will it trap heat?
Yes, if it is too much CFC, it can trap. Yes. Even more carbon dioxide.
We can customize the atmosphere.
Sorry, again, please.
That's how we can customize the atmosphere, Martian atmosphere.
I cannot get you. Sorry.
Can we make it livable, Martian atmosphere, by trapping heat and artificial cloud, releasing artificial clouds to make sure there is availability of water? And
what do you mean by artificial cloud? I cannot get that.
Like there in the dry areas like Saudi Arabia, they use artificial clouds to make it rain.
Ah,
That's how.
I also discussed in, I don't know where I discussed that, maybe in your class also. Artificial cloud is artificial cloud seeding. That means you have the cloud, now you wanted to go for a rain. Okay, you need the water yourself. Artificial cloud doesn't mean you create the cloud. Cloud is in there, but the cloud don't have enough capacity to be rain, to be poured down, to come down to the earth surface. That time we go to a couple of other things. For example, one chemical is silver iodide. We can go on the top of the clouds, and we just seeding that silver iodide on the top of the cloud, and then cloud come together, make very the temperature going to be very cool, and then water droplets come, and then it can give you some rain. But it is also not well accepted throughout the scientists, because it is not working all the time. But your cloud should be there, water should be there. Now if you want some cloud in the Mars, then you need some water in there first. You need some gaseous particles, so that it can start it to make hydrogen and oxygen to make contact to them, and they should come together to form water first. I don't know this is possible or not, but this is the way how you can expect, but not
Yes, sir.
artificial.
So, I have another question out of context, but American submarines use water to make oxygen from it under the water. Yes, that's how can we release hydrogen and oxygen together and make it rain?
It can be possible, but how much? Can you understand from here to Mars? Even it is with the very high confidence, it's still what are the planets that the scientists can go, and then you wanted to take a huge amount of the oxygen and hydrogen to start some chemical reaction in there. It is, I think, maybe it will be possible some other times, maybe in future generation, maybe some out of 100 years after, maybe it might be possible. But at the present context, I have no idea that there is the possibilities to have these things. But maybe in future it might be possible, because there might be some other type of chemical reaction that can be improved and explored, that can also trigger the liquid surface on the top of the Mars. It might be possible. And as you said, if you can release CFC and others, yes, obviously you can release it, but think about the distance from the Earth from to the Mars. It is huge, no? And
Scientists have a way they have predicted if nuclear bombs are dropped there, a huge amount of greenhouse gases will release and make it warm.
Maybe that's what I'm saying. There are many possibilities, but it is all of the possibilities is in the theory phase, not any practical sense. Because according to my knowledge, I don't know what are you giving. You are giving references from various sites. It's okay, fine, but scientists, all of these are theories, and it might be possible. I'm saying maybe possible, but not at this stage of scientific innovation. Maybe it is possible after such more innovation, after a couple of another 50 or another 50 years after, or another 100 years after, I don't know. With the more development of the science, it might be possible. But at this stage, what are you talking about? It is not still in a very practical sense we can make it.
Thank you, sir.
Okay. Any other question? Okay, so thank you joining me in this class. Maybe we're gonna start a new chapter on clouds on the next class. Thank you all.
Assalamu alaikum, sir.
Wa alaikum
Assalamu alaikum, sir.
Assalamu alaikum, sir.